Hello, this is Diego Apellaniz. In this tutorial, we are going to use ChatGPT to create a sophistic model related to our reinforced concrete slab. So we will use ChatGPT to generate our code in the programming language of Sofistik. And this is actually a pretty big challenge because we are not just teaching ChatGPT about a new API, but about a whole new programming language, which is of course the Sofistik or Teddy language. And not only that, we will also see how we need to talk to ChatGPT so that we speak about general building terms and ChatGPT automatically translate that into the Sofistik code. And finally, we will have some reflections about how to automate this workflow for future projects so that we work efficiently. And we will see some comparisons between ChatGPT 3.5 and ChatGPT 4 related to our particular case study. So let's get started. As you probably know, this is the text editor of Sofistik or Teddy, and the way of defining a Sofistik model is to write our code in this text editor. And the way to write this code is not with plain text or any programming language. It is using the CAT-IMP, and CAT-IMP is the own Sofistik programming language. And as you can see, these are different records or commands, and basically the model or the code is broken down into different modules. So in this case, we have the first module, Aqua, to define the materials and cross sections, then Sofimesh to define the model geometry, and so on and so forth. And once everything is defined here with this particular syntax of Sofistik, then you can basically calculate the model. And in this case, it is already calculated, and you can click here on System, and exactly, and you should be able to see the results. Okay, so I've just opened my browser, and of course on chat.openai.com, and the idea would be to use ChatGPT to generate our code for Teddy so that we generate our model in that efficient way. And for this tutorial, I'm going to use GPT-4, right? Because I'm paying for the plus version of ChatGPT, so why not? And of course, the first that we want to check is to see if ChatGPT is already familiar with Sofistik and more specifically with Teddy. So that's what I've just asked. And GPT-4, he says, okay, yes, I'm familiar with Sofistik. And it seems that it already knows what Teddy files are, and it's about to give me an example of a Teddy file. Okay, so it is already done with the example, and at least it says that it recognizes it as code, although it identifies Teddy with SQL, which of course it's not right. But anyway, we can just copy the code by clicking on there. And let's, okay, but I'm a bit skeptical, so let's just test it. I'm copying it on Teddy. And as you can see, it's a bit suspicious because it doesn't recognize the comments and the keywords and so on and so forth. And of course, if we click on calculate, we're going to get errors left and right. So, okay, it seems that it knows what Teddy is and Sofistik, but it doesn't really know how to write code in Teddy. And that's what we're going to do right now, how to teach ChatGPT to generate this code for us. Before jumping into ChatGPT, what we're going to do is to draw up a plan of the different steps we are going to follow so that it's more or less clear. And basically, what we're going to do is to, as you know, Sofistik is defined into different modules, and we're going to start with the module named Aqua. And with this module, what we define is basically both the materials, and the cross sections of our model. And that should be pretty straightforward. And once that is done, we're going to move on to the second module, which is going to be Sofimesh, actually Sofimesh A. And with this module, we are going to define the geometry of our model, and we are also going to assign the mechanical properties, right? And in this case, we are going to define a relatively simple reinforced concrete slab. It's going to be a rectangular reinforced concrete slab, something like this. And this slab is going to rest on columns along its perimeter, which have a separation of about 8 meters. And besides these columns, we are going to define a concrete core here, which for this slab is going to mean that there is an opening. And of course, the concrete walls are going to be represented as line supports. Also, later on, once this model is defined in a second iteration, we are going to tell ChatGPT to replace these two columns here by a concrete wall along this side. And also, I haven't said it, but so that ChatGPT understands the geometry of the model better and we can tell him instructions, it is very helpful, although it is not mandatory in Sofistik, but it is very helpful to define some axes on our model. So these are going to be the axes A, B, C, and D. And these horizontal axes are going to be 1 and 2, exactly. And once this geometry is defined, of course, with the proper cross sections for this slab and so on and so forth, we are going to move on to the third module of Sofistik, which is going to be the module Sofiload. And with Sofiload, what we basically do is to define the the loads of our structure, right? That should be pretty straightforward. So we are going to tell ChatGPT to define the self-weight of our model and also some rectangular free loads. So for instance, we are going to have a live load case with two different free rectangular loads, one defined on this part of our slab, and the other one with another value defined on the other part of our slab. Something like this. And besides these surface loads, what we're going to do is to define a line load, right, representing the building facade, which is going to follow the perimeter of the slab up until this concrete wall, right? Here over our line support, we're not going to draw any line load. So that's basically it. And finally, of course, although we're not going to do this with ChatGPT, but the last part is going to be to use the final module, which is ASE, to run the analysis of the structure. Okay, so now what we're going to do is to use some prompt engineering principles to get to teach ChatGPT how to he can be an assistant for us by generating our TEDdy code, right? And the first thing that we're going to do is to not just jump directly into the first part of the Sofistik code, but we're going to give ChatGPT a general instruction what we want it to do. And so first we say, okay, I want you to be a code assistant to generate a calculation model in the finite element program Sofistik. So it assumes that role. And later on, what we are going to do is to explain a representation, a description of our model, but just talking in general terms, right? So the idea is that ChatGPT identifies the, let's say, the code aspects of the TEDdy file with the actual building elements so that we can talk to TEDdy in the end in plain text, right? We can talk about walls, about columns, about that part of the building, and it understands that. So this general description is very important. And then we explain what we are going to ask him in following questions. We basically say that we are going to deal with these modules, Aqua, Sofimes, Sofiload, and ASE. And we explain what this module do, in case that it didn't know that already. Moving on, basically what we are going to do, the way that we are going to teach ChatGPT to generate write TEDdy code is with two different things. First, we are going to show TEDdy or ChatGPT, sorry, the syntax, right? The correct syntax of the records or commands of Sofistik. And then we are going to provide ChatGPT with some examples as well. And once it has this information, then we can ask to generate the code for our particular example. And in this first instruction, in this first general instruction, this is basically what I'm just saying. I'm going to provide you with the syntax in this format, actually in some kind of JSON format. Apparently it understands it this way, but if you come up with another approach for providing ChatGPT with this data, just let me know in a comment, please. But this worked for me, so we're going to explain the record name, the keywords, the values, and so on and so forth. And this is an example. So this is going to be the record name, and these are different ways in which we can provide the different values for those parameters, right? And finally, this is more important than it seems. Wait for further instructions, do not write any code yet, and also keep your comments outside the code sections as short as possible, right? Okay, so basically what ChatGPT is telling me is that, okay, thank you for the explanation, and now I'm ready to go. So we are going to jump into the first module, Aqua, right, to define our materials and cross-sections. But the code that ChatGPT is going to provide us with, we don't need to understand that as a perfect code and ChatGPT is going to do all the work and so on and so forth. It is just an input for us. If it's 95% right, it is okay. We just want to work more efficiently, right? But we don't strive for perfection. We strive for efficiency. So let's start with the Aqua section. That's what I'm telling. And now here comes the description of what I want ChatGPT to do. In my model, I want to use this code, and I want to use this material, and this concrete material, and this steel reinforcement material. This is just my custom requirement. But of course, now what I have to do is to provide ChatGPT with information how to generate the proper code. So first, I provide ChatGPT with the syntax of this module, and I'm not passing the whole help documentation of Sofistik because that's very long, right? But in this case, I'm just passing the keywords or records that I want for this particular model, right? Like norm, concrete, steel, and that's it. And with the keywords, the same. I'm not passing all the keywords, but just the ones that I want for this particular case. But I don't know, I might expand these prompts for future projects. And besides this explanation of the syntax of Teddy, I'm also providing an example. And this example, it is very important that it is clear, right? And it's clean. And also, it is important that we use comments. And we use comments for two different things. First, to explain or to let ChatGPT know what we are doing at each step. And secondly, to explain how ChatGPT has to understand certain kinds of data. In this case, okay, I'm telling you here C35, but it is going to refer to this concrete quality, because the idea is that I talk in plain text to ChatGPT. So I'm going to say I want a certain concrete with this format, but he just needs to get the first number from my input. And this is then the what ChatGPT generated. Okay, so this is the code for the Aqua module, and let's just copy it and let's test it. Aqua, the definition of my module, the code, the materials. So let's calculate that. And everything was right and perfect. You have to take into account that this was actually the only text that I provided for my project. The remaining text was just to teach ChatGPT and to train it if you want, and we can reuse this text for future projects. And another tip is that we have to keep its conversation focused on a particular project. We don't want to, let's say, mix things up here, because then we would end up confusing ChatGPT. So one conversation, one chat for one particular project or one model. And the other thing is that, okay, this is my my code with Aqua, everything worked perfectly, but in case that I'm not satisfied with the code and I want ChatGPT to do that again, what I want to do is not to write another message below. We are going to rather click on this button, edit, and this way we can edit our code if we want. Okay, so let's move on to the next module, which is Sofimage A, right, to generate our model geometry. And this module is a bit particular because the geometric description of our building may be pretty complex and we don't want to confuse ChatGPT, so probably you want to break down this prompt into several prompts, right? Not to give the whole description just in one go. So let's go for it. And now what we say is, okay, that was great. Now let's move on to the module Sofimage A. And I want you to define a rectangular slab of these dimensions, 24 by 8 meters, in X and Y directions, and with this particular thickness. And we say there is a column grid, which is translated into point supports every 8 meters. And again, you have to notice this relationship that I try to transmit to ChatGPT between the model elements, the columns, and the code, in this case, related to the point supports. And also, so that ChatGPT understands our instructions, which are going to be related to the building, not to the code itself. It is very helpful to define an axis system. So writing out axis as a comment, and the x coordinate refers to the grid axis A, B, C, and D, and the y coordinate to the grid axis 1 and 2. Again, this is not a requirement for Sofistik and Teddy, but if ChatGPT does that, then it is going to understand our further instructions much better, and assign that particular material. Okay, so that was our instruction. And now, of course, first we provide ChatGPT with the syntax, and again, this is just the keywords or the records that we are going to use here, but it doesn't need to be the whole Sofistik documentation. And also, we provide ChatGPT with an example, and this is the example definition of another slab system. And again, the comments refer to what we are to what each section of the code is doing. And also there are other comments that explain how to provide, how to write Teddy, right? So for instance, the node constraint indicate a point support, and note that all node properties are defined in one unique line, right? So that it doesn't define the support later on. These instructions are really helpful. So we don't want to provide ChatGPT with just any Teddy file that we have exported from anywhere. We want clean examples here. So that was our input, our prompt. And this is what ChatGPT generated. In this case, okay, based on your requirements and the provided syntax, here is the Sofimers A section for the Teddy file. And it defines the system type and the nodes. And notice how it is defining the supports in the same line as the nodes, which makes sense. And also how it defines the grid position or the axis, right? So this node, it could be A1, B1, C1, and so on and so forth. So this looks actually quite good. So let's paste it here. And now we're going to click on Run. And that looked quite well, actually. And exactly, this is the geometry of our slab, or at least in this first iteration, with our supports here. Fantastic. Okay, but as we saw, as we said in the previous explanation, this is not our complete model. We also want an opening here, which is going to be our concrete core, and we want a wall support here. But we have just provided ChatGPT with this first iteration so that it is more or less simple and it doesn't make any mistake. But now what we can do is, okay, it was great, but now update the Sofimers A module to add a square opening of 4 meter side length. I made a spelling mistake here, but that's not that bad. Centered between the C and the axis. And notice how now I am able to refer to the building axis because ChatGPT wrote those down in the as comment in the code, right? So that was very helpful because again, I'm talking in plain text, I'm talking about the building, and ChatGPT translates that into code, which is amazing in my opinion. So this could be the updated code with the new nodes, right, related to the opening, and also with the opening itself, and with the line supports related to the concrete walls, right? I haven't specified the rigidity, the stiffness, but I guess for this example, it is okay to take those default values. So I'm going just to update Sofimers here, and let's calculate it. And this is how it looks like. So now we can see how our concrete core, represented by an opening and these line supports, has been included into our Sofistik model. And you can see how step by step we are getting to our goal. But we are not done with Sofimers A yet. Exactly. And here we say, okay, and we want to update the Sofimers module again. Remove the columns on the node A1 and A2. We are referring to the grid system. and add a wall represented by a LAN support connecting those nodes. And it updated the module. And by the way, in this case, it was pretty simple because ChatGPT had just written the Sophie Mesh module here. But if we're asking ChatGPT to update a part of our TD file that it wrote several messages before, it might be a good idea to write the code here below that we want ChatGPT to update. But in this case, it was necessary because that was just the message right before this. Okay, so anyway, this is the updated Sophie Mesh module. Let's just copy everything and let's check if ChatGPT managed to model that particular wall and remove those particular columns. So let's run that. And this is our updated model. And we can notice that, first of all, the columns here are gone, right, in these grid locations. And we have our concrete wall represented by this line support. So I think that we are done with Sophie Mesh and everything worked just fantastically. And finally, let's move on to the Sophie Load module, right, to generate our building loads. And yeah, the process is pretty much similar. And we say here, let's move on to the Sophie Load section now, and those are my requirements. Generate the self-weight of the structure and a permanent load of 2.5 kilonewtons per square meter applied to the whole area elements. And also I want a live load case with two rectangular loads. The first one applied to those to that particular area between those axes, and the other load to those particular axes. So you can see how it was a great idea to define the axis, right? Because now we can explain to ChatGPT about that, and it understands that perfectly. And with those particular load values, and this is the syntax of Sophie Load, right? Of the keywords, the records that we're going to use. And this is the example. And here we explain each section. And we say, okay, but in this case, you have to define all load cases under that particular action and so on and so forth. I know that there are different ways to define TD syntax or cat int syntax, but if we show just one way, it is fine, right? And yeah, so this is our example. And of course, we are showing different load cases, different actions, different loads. And that's basically it, but also it is very important to finally exactly apply that line load in another load case along the perimeter of the entire slab. If you remember, we said that we don't want that line load on top of our line support, but we're going to add that in a separate step so that we don't confuse ChatGPT. So this was and by the way, I can just copy it by clicking on here. So this is the result of ChatGPT. Let's go back to TD and copy it. And also, to test it, what we're going to do is to add the code related to the ASC module. And this final module, exactly, it just basically runs the analysis of the module. We're not doing this with ChatGPT for those reasons. First, because we have the code, and we don't want any modification, and secondly, and we mustn't forget this, because the code is independent from the other modules, and we are not going to refer to that in our ChatGPT conversation later on. In some particular case, we may want to copy some code for other modules like Sophie Mesh or Sophie Load, but on those situations, it might be a very good idea actually to tell ChatGPT about that. So we just write a message, okay, ChatGPT, we are going to define these module elements with this particular code. Why we are doing that? Because later on we may refer to that model, to those elements, to those loads, right, that we have just copied. And if we let ChatGPT know about that, maybe we can later on do modifications with that information. But in this case, ASC, it is just pasting this code that it has no relationship with the remaining code lines, so that's fine. Anyway, let's test this. And perfectly, I got a warning, but I think that's just because there are loads on the opening. But for our case, it is okay, and we can see the deformation here, which looks great, right? We have our dead load, which should have both the self-weight and the distributed load. But actually, let's use this other module so we can see the results properly. And this should be 3D, we want to see the loads, all loads, and this is the load. Exactly, we have both the distributed load and the self-weight. And then we have our live load, and we can see that we have two different rectangular loads as we asked ChatGPT to do. And finally, we have our line load along the perimeter of this lab. And the final step is going to be to ask ChatGPT to remove this particular load from here. So, because that's our line support. So, no, I don't want to save that. And here, okay, but remove the line load of the load case 3 above the wall, please. And we are just saying above the wall. ChatGPT knows exactly where that load is located. Or that's what we expect at least, right? And so this is our updated Sophie load module. We run it again, and we can see how this line load is gone. It's no longer there. So everything was fine, and I think that we're done with our Sofistik model now. Yeah, exactly. That was everything that we hoped for. Okay, so just two reflections or conclusions before finalizing this tutorial. First, this is a Word document which includes all the prompts I provided ChatGPT with, and of course I will link this document from the description of this video. And I just want to say I have highlighted these red parts are basically the prompt sections that refer to the actual model. And for the next project, what you need to do is just to update these red segments. But as you can see, this is actually very, very quick for a complete model of a slab system. This is very, very efficient, right? You just need to prepare the text for teaching ChatGPT once. Maybe you are going to expand that in the future. But for future models, we just want to update these short red sections. That was the first idea. And finally, another conclusion is, of course, the comparison between ChatGPT 3.5 and ChatGPT 4, the one that we have used in this tutorial. And first, I have here this comparison of the module Aqua, right, for the definition of materials and cross sections. And here you can see this is just a small mistake. Well, first of all, ChatGPT 3.5, it doesn't recognize this as code. It thinks it is normal plain text, which it is dangerous. That being said, in this case, it didn't understood from our comment that it just needs to take the first number here, right, the 30, to define the concrete quality. So our prompt or this answer from ChatGPT would have led to an error in Sofistik, but that was just something small, right? We can just edit it manually. That's no problem, but the big issue came with Sofimess A. With Sofimess A, our goal, right, it's to talk in terms of building elements in general terms, and the idea is that ChatGPT understands that and translates that into code. And for that, the main thing we did was to describe a certain column grid, right, with this axis from A to T and from 1 to 2. And ChatGPT-4 understood that perfectly, but ChatGPT 3.5 was clueless. It had no idea what those grid lines were about. So that was the first thing. Then ChatGPT-4, that was pretty cool in my opinion. It understood the unit conversion, right, from meters into millimeters, because in the example the units were given in meters, but in the explanation of the syntax we provided ChatGPT with, we said that if default units were millimeters, so it just translated our 30 centimeters into 300 millimeters, which was pretty cool. And finally, the last thing is that, yeah, of course, ChatGPT 4, although we didn't say that in the description, but of course it included these commands, right, or these records for the image generation and so on and so forth, because that's necessary. He took those from the example. And ChatGPT 3.5 had no clue that it had to do that. So that was another issue. And I didn't go on with Sofimess, Sophie load, and so on and so forth, because at this point it was pretty much clear that you need ChatGPT 4 to generate the files. So that was it. Thank you very much for your patience, and see you in future tutorials.